Hello, I'm Brian Wood, and today I'm going to talk to you about enhancing RAG pipelines. I'm a solutions engineer here at Snorkel. And so first we're going to talk about what is RAG and why it needs to be customized and how we do that within the Snorkel Flow product. Imagine this, all right, it's 2020 and you're using GPT-3 and you're trying to plan a picnic. So this is kind of ancient for AI at this point, but you ask, what's the weather like in New York City? And the model says it's a high of 75, it's a great day, go forward with your picnic. And so you do this, you plan it, you go out, and unfortunately it's cold, it's rainy, and you're gonna have a miserable time. And of course, this is because this was pre-RAG. This was when everything the model knew was stored within the parameters. It didn't really know anything that wasn't in the context. And just to kind of give you like a real world experience, I used to work at Bank of America. I managed a team of data scientists there. And the first time I used AI at work, generative AI anyways, was to write employee reviews because I'm always looking for a shortcut. And so I'd have my team, they would fill out their self-assessments. I just kind of take their bullets, dump it in GPT-3. Everything looks great. It looks like I spent a lot of time doing it and I was very thoughtful. GPT had a much better tone than I did. So I immediately fell in love with using Gen AI at work. But I had to put all that data in the context because these LLMs, they don't know anything about your private data. They can't answer these questions. So when I'm asking it to review an employee, it doesn't know anything unless I've put it in there. And they often can't answer questions about public information either. So in this example, we're asking about the fair value of an interest rate derivative. This is in Visa's 10K. You can find it out there on the web. It's probably in the training data for these models. And if we ask it this question, it's going to, give us a factual kind of general answer. It's going to tell us how to find the information, but it's not going to actually answer the question. But if you go out to the document, you can see on page 85, the answer we're looking for is 138. But we had to go find that. And the whole point with this is trying to get it to answer a question for us. So what you could do is take page 85 and paste it into the model, ask your question, and it's going to give you the right answer. But you didn't really save any time by doing that, right? You still had to go find the document, you had to find the right page, and you had to paste it in there. So it's what are you even doing with Gen AI? It's just pulling a number out of here. And so you might think, well, I'll just throw the whole document in there. I'll throw all the documents in there. And that's a solution sometimes, putting everything in the context. To be sure, larger contexts are coming. This is less of a problem as it used to be. But as was mentioned, I think it was Chris Glaze on the main stage earlier, he mentioned this problem of lost in the middle, and that's going to be an issue. But the issue here is, here we've pasted 20 pages of information into ChatGPT. It's got page 85, it's got the answer, but it's not finding it because the answer's in the middle. The model just doesn't see it. And this is that phenomenon that was mentioned earlier about things getting lost in the middle. So you can't just dump your whole knowledge base in your context window. You might get away with one document. And one thing I learned earlier was that this is actually even a bigger problem with O1 Preview Mini. I didn't know that. I learned that today. It's kind of counterintuitive. You always think a new model comes out, it's going to be better. So that was kind of an interesting thing to know. Sorry, I don't know if I'm in the way here. And the other thing you see too is this is a very common problem. It seems like no model, no architecture, well, they're all kind of the same architecture, but basically no model is immune to this. Like we learned earlier, O1 Preview gets things lost in the middle. And so what that means is you need to provide specific information for these models to be able to retrieve an answer. You can't just dump your whole knowledge base. Even if the cost of doing so goes to zero, it's not going to find the right answer if you just dump everything in there. So we have to break our documents up. You might have tens of thousands of documents. You might have 100-page, 400-page documents. And what you have to do is break them up into chunks so that these chunks can then be used in the context window. So you're not having a lot of irrelevant information. And this is kind of a classic problem of precision versus recall. If you put too much information in there, the model's going to get confused on some of the irrelevant stuff. And of course, if your chunks are too small, it's going to be missing critical information. It's going to fail to answer the question. And we'll get into dynamic chunking later. But also, how do you know which chunk to retrieve, right? If you've kind of cut up your documents, instead of one document, you have 1,000 different chunks. What do you do with those, okay? And that's where embedding models come into play. And I know this is probably a technical kind of practitioner audience, so I'm just setting the stage. I know you guys are probably familiar with most of this, but the way I like to think about embeddings is that it essentially gives us like an end-to-end mechanism to work with language, right? Because this is going to convert the language into a format that the computer can understand and interpret and repeat back to you. And so embeddings allow us to do that on our knowledge bases. And they also tend to learn how to clump things together. This can be good when you're trying to retrieve similar subjects. But one problem that you'll start to notice is that it starts to lose some of the nuance as things clump together. And that's going to be really important in enterprise situations. So even if you get your chunks though, right, you still got to figure out how to get them in your document. And that's where RAG comes in. So this was introduced in a 2020 white paper that was published by Facebook. This was pre the rebranding. It's Meta now, but I went with Facebook since that's what they were called at the time. And it's basically an architecture for like, how do you set up an end-to-end system of being able to retrieve context and pull that in when you're generating a response. So you don't have to go find your document, you don't have to go find the right chunks, et cetera. It just happens. And this is obviously like a cartoon version, but basically it's just introduced this retrieval system. So instead of having an input and an output, we've now got a step. And we're gonna see in the next few slides that these things can get pretty complicated. But just to ground us all, this is kind of the lay of the land. So to zoom out a little bit, I mean, this is what we've just talked about, right? You've got documents, that's your starting point, that's your input. You're gonna have to break those into chunks, convert those into embeddings, and then you'll store those in some type of vector database. This is all stuff you're gonna do kind of offline. When a query comes in, if somebody's asking a question, this is where your retrieval system comes in. So it was just one little box on the last slide, but now we're breaking it up a little more. That query is gonna get embedded, and then it's going to get compared to your chunks. It's going to create relevance scores for all of those. It's going to pull back the most relevant content and then put that in your context window for ultimately generating a response. So this is kind of the framework we're going to use as our end-to-end system. And sorry if I'm clicking too fast. I see people with the cameras. I'll try and make sure you guys get the pics. But we're going to focus on the retrieval side. Like at Snorkel, we found it really effective to think of things in terms of like retrieval errors and generation errors. And Rebecca was just up here walking you through how we do eval in Snorkel. And that's always the starting point. You really need to kind of figure out, do you have retrieval errors or generation errors? And I kind of work out in the field. So I'm meeting with customers, every day, multiple different customers, kind of learning about what their problems is. And what I find, and like one of the reasons I'm really interested in the retrieval topic, is this tends to be where these systems are failing. It's also a great place to start. So if you don't know why you're getting bad responses out of your system, it's usually a decent idea to look at retrieval first. And think about it this way. If you don't have the right content in your context window, then it really doesn't matter what your LLM is doing. It has no chance of getting the right answer because the right answer is not in there. Another thing, just to kind of build some intuition, let's just say you've built a chatbot, you've got kind of an out-of-the-box RAG system set up. If you find that the responses are like hallucinations, like what the answer is, but you're getting the wrong answer, that's probably a retrieval error, right? It's either not getting the content or it's getting the wrong content. It's going to manifest itself as some sort of hallucination. The other thing you might see is the model abstaining. It might just say, I'm sorry, but I don't have that information in my context. So that's another kind of signal that you have a retrieval error and that you need to start looking at these systems. So let's talk about how to optimize these, or why you would do it in the first place. And this is really, in that kind of same thread of where Snorkel fits, which is customizing your AI through data development. Out-of-the-box systems, and we'll dig in, are going to have, a lot of problems where they're just too general and they need to be trained on your data. So particularly if you're like working with very nuanced like finance or healthcare technology type topics, that nuance generally is not going to be captured by an out-of-the-box model because they haven't been exposed to your data. And I think, a couple people here are probably using this use case. It's anonymized, but I really like it because it kind of shows that in this example, it's based on this is an actual example that we helped a customer with. They're using Llama Index and GPT-4, which at the time was, state of the art. There's no fault in using that as your out-of-the-box RAG system. It's a good embedding model. It's a good generation model. But their SMEs were only accepting the responses and calling them accurate 25% of the time. And what we found through evaluation was that it tended to be retrieval errors. And we ended up doing a couple things to assist them. One is creating additional metadata around the chunks and documents, which we'll look at. And the other was fine-tuning an embedding model. And so what I really just want to show here is, the type of improvements you can get by focusing on retrieval errors. All right, so key takeaways is, that we're going to look at is the whole pipeline matters. Everything is something to be optimized. So let's start with chunking, all right? We've kind of already gone over what this concept is. It's cutting up your documents, making sure that you have the right, size of chunks. And again, like I mentioned earlier, it's precision versus recall. If your chunks are too large, you're going to have irrelevant content. If they're too small, you're going to miss things. And so let's talk about dynamic chunking, right? You want to kind of really build chunking that is tuned to your documents. And so we'll look at a couple different examples. And just to orient us, we're going to start in the top left and work our way down. And there's a couple ways you can do this dynamically. One is kind of semantic and topic-based. So in this case, we're looking at articles that have a couple of different concepts. There's topics about the Canadian Broadcasting Corporation, topics about an album, and topics about a book review. So if you're asking a question about the album review, you really need all of that content. You don't just need a piece of it, and you certainly don't need anything about the book review. And so by breaking your document up based on topics, you can be sure that, when asked a question about the book review or the album review, you're going to have all of that information in your chunk. It's not going to be missing anything. So doing it based on topics and sort of natural flows or overviews of a topic is one way to do it. Another thing we see pretty commonly is formatting things. So like with tables, for example, on the left, you can kind of see an illustration of how a table could get chunked up if you're using just a fixed size. This is obviously going to struggle when you put it into a context window because you're missing headers and just a lot of other information. And then this multi-column problem, for anyone that's worked with OCR engines, you've probably run into this at least once, where it's kind of a gamble on if it's going to get it right or not, or if it's just going to put a lot of space between them. But looking at the layout of the document and breaking your chunks up that way is going to be effective strategy. And then also looking at sections. These are obviously organized for a human to read. There's a section header. It tells you what's going to be in there. And if you're just arbitrarily cutting part of a section out or doing it halfway, you're going to have incomplete information when you deliver this into your context window. The best example I ever saw was with a policy document where, the intro to the section says that the following things are not allowed. And that part was cut off, and then it had a list of things that, these traders were not supposed to do. And the model was ultimately, hallucinating that, that these things were allowed because that semantically it was most similar to the question that was being asked. So you don't have to miss much, right? Just a couple of keywords can really throw the generation off at the end of the day. And so by doing this by section, you're getting these semantically, conceptually complete pieces of information. Now, this is available through the SDK within Snorkel. I can't necessarily show you like a UI workflow for this, but through the extensions in the back end of Snorkel, some of these tools are already built in. They can also be customized to your product. And so that's kind of the starting point, right? Is just getting the right chunks in the first place. And so the next thing we'll look at is metadata. So as we kind of talked about with the chunks, those get turned into embeddings. And the purpose of the embeddings is to capture that semantic meaning of a document. The reason you might want to also include metadata, though, is because sometimes structured information is more precise and easier to filter. So maybe you want to know the date of an article, the author, the topics, specific products that are mentioned. A semantic model using embeddings and relevance scores isn't going to always get that precisely. So this is a case where having structured data is going to help you. And essentially just provide additional data points for your retrieval system to locate that information. So this is kind of in support of your vector database combining the structured data with the vectors to retrieve the most relevant information. And I think most people working on RAG systems have done what we now call like traditional NLP, which is like classification and extraction. And so if you've used Snorkel Flow for any of those types of use cases, you know, where you're building a classification or extraction model, this is probably going to be fairly intuitive. It's basically what you're doing is trying to just build that structured information about your document that's going to go either in your vector database in a separate database. It could possibly go into a separate search index, but it's going to ultimately become part of the information that your retrieval system uses when looking for the correct context to put in your generation. Just another example. All right, this is kind of the fun part. This is where things start to get interesting, is actually tuning your embedding model. And this is where we see a lot of lift with customers. So as I kind of mentioned earlier, these embedding models are designed to clump things together that look alike. That's great when you're trying to embed all of the knowledge in the whole world, but that's probably not your use case, right? You probably have a specific industry, a specific company, and maybe within that company you're dealing with a specific topic or organization. And so what I want to do is kind of visualize this, right? And so on the left we have a pre-trained model, and you can see we have financial concepts and health concepts. And those concepts get grouped together, right? We know finance stuff goes over here, health stuff goes over here, but we're working at a bank. And so we don't necessarily need a model that understands, you know, health information. We really just want it to understand more nuance within finance information. So the goal of tuning a model like this is really to start to create the view on the right. So these are more fine-grained financial concepts. You know, instead of everything being grouped together, you have savings accounts, pre-tax investments, tax-deferred investments. And the idea is that you're creating this space between them so that when you create relevance scores, you can find the most relevant information. And so kind of to go down a little bit more in the weeds on a specific example, let's say we have a document and we're asking, what is the last date this deal can go effective? So this is an example from a banking customer looking at collateralized loan obligations. And we just want to answer that question, what's the last date? And we can see that, you know, we have relevant content and irrelevant content. So the agreement must be executed and operational by X. That's the content that we want, that has the answer in it. But it essentially overlaps with content that's irrelevant, but also has some dates and some, you know, finance-looking stuff in it. And what we ultimately want to do by fine-tuning this model is, again, push the question and the relevant content closer together and push everything further apart. And so the way we would do that is through data, right? We're not going to build an embedding model from scratch. We're going to create these pairs of question and context. So in this case, we know the questions that we want to ask the document. And all we have to do, it sounds simple, right? Just find the chunks that are relevant and label it with the question. It's sort of like a classical classification model. And by creating that data set, we can then, you know, execute our fine-tuning job. So one way to do that is to do it manually, right? You take all 10,000 of your documents and you break them into chunks, and you find every chunk in that document that's relevant to that question, and you manually annotate it. I think by coming to SnorkelCon, you kind of know what the pitch is here, right? That's going to be a burden. You're not going to have enough SMEs to do it. It's going to be slow, unauditable, ungovernable. But it is a way you could do this. You could manually annotate the data to create those pairs of questions and context. The other thing you can do, particularly when you don't know all of the questions that are going to be asked, or you want to get kind of a, let's just say, more diverse data set, is through synthetic data generation. So you can take your data chunks and you can use an LLM to generate questions from there. It's a really great way just to get variety in your data set. However, if you ask an LLM to generate a question and you give it any information, it's going to be really, really happy to just make up a question. So one of the easiest ways to think about this is like, imagine like a table of contents of a document, and it's going to say something about loan effective dates. If you feed that into a model and say generate questions, it'll come up with these really creative questions about loan effective dates that cannot be answered by the table of contents. On the other hand, it's also going to create some really great questions. At the end of the day, you'll only get kind of minor lift because it's kind of, there's just a lot of noise in there. You're going to have some really good questions, some really bad ones. So 2 ways that Snorkel Flow can help is enabling users to programmatically annotate the relevant chunks. So you would annotate manually, just like we talked about on the last slide, a subset, and then codify that knowledge in labeling functions, and that's what's going to give you the ability to annotate your whole data set at scale. The other thing is using labeling functions to filter down your synthetic questions. And there's a lot of creative ways to do that. You can use heuristics, you can use keywords. You can ask another LLM to take the question in the context and tell you if that question can be answered or not. You could go ahead and just convert the question and the chunk into embeddings and see what the relevance score comes out to be, and only take pairs that are close to each other, since that's ultimately the goal. And so ultimately your data recipe ends up being kind of three-pronged. You're going to have your manual annotations. That's always kind of the starting point, the gold standard. You're going to have the data set that you've labeled programmatically by kind of scaling up the knowledge from those questions. And then finally, you're going to have your synthetic questions that have been filtered down. You combine all of those into the fine-tuning algorithm. So now that we have a really robust, high-quality, diverse set of questions and context pairs, we can fine-tune our embedding model. And here's the result that we would expect. So this is based off that use case that we saw earlier, where we saw such an improvement in the scores. Before fine-tuning, so this is the relevance score. 0 means that they're not related. 1 means that there's total overlap, and the count of the prompt and chunk pairs. So you can see the non-tuned model, relevant and not relevant content is barely distinguishable. It's basically coming up with the same relevance score. So when you feed this data into your retrieval model and it looks for the most relevant content, it doesn't do a great job because everything looks the same. On the right, this is after fine-tuning. So we've built this data set of question and context pairs. We've tuned an embedding model. And now when we retrieve that, the relevance score for the relevant content is near 1, so that's an excellent result. But more importantly, the not relevant stuff is not overlapped as much. And this is ultimately the goal of tuning that embedding model. We're creating that space between the relevant and the irrelevant content. And so that leads us into the last thing we'll look at, which is the retrieval model. Because the point of what we were just doing was to ultimately come up with these relevant scores. So now it's kind of like, what are we going to do with them? And so this is this whole middle part of the diagram. And so when somebody is asking a question of this model, it's using the retrieval system. It's going out, looking in the vector database. It's looking for, it's essentially calculating a relevance score for all your chunks compared to the question that was asked. And then it's, kind of an out-of-the-box system is going to take the most relevant content, right? That makes sense. That's very intuitive. But this does become another thing that can be optimized. So a lot of these systems might just take like the most relevant chunk or the top 3. But what that could do potentially is, not optimize the use of the context window. So let's say, we're using a model where we know that a certain context window size is going to perform well. We're not going to have that lost in the middle problem. Then we want to take advantage of all of that. We want to, use as much context as we can so that the model has the most likely chance of getting the right answer. And this is all kind of deterministic, right? At this point, we've got the relevant scores, and it's more about just sort of ranking things. And this is just a flavor. I mean, one thing I really want to highlight, and this is true of the retrieval model in this whole presentation, is that, none of this is really exhaustive. There's pretty much every part of this can be optimized. So just a couple more examples of what you could do is rewriting your queries. So when a query comes in, the user didn't write that query to optimize how it was going to be embedded and how relevant scores were going to be calculated. But an LLM or a small language model even could rewrite that query to optimize it for your embedding model so that it ultimately has a higher chance of a high relevance score when compared to your chunks. Another thing you can do is result re-ranking. LLMs are really good at this. I've seen some examples where you get 20 or 30 points just by implementing this. So imagine, you have 10,000 chunks, right? You calculate relevant scores for all of them, and you pull in, let's say, the top 50. Because you can't run all 10,000 of them through an LLM. It's just not going to work at inference time. But taking those top 50 relevant scores and then putting them in another LLM to re-rank them, it might find that like result number 45 actually should be result number 1. And this can usually be done at inference time because it's not that much data and the models run pretty quickly. And we've seen huge improvements just by implementing that technique. And then another thing is retrieval routing. It's not always a technique to improve the quality of your retrieval, but if we kind of think back to where we started, like trying to plan a picnic, like all that information is not going to come from the same place, right? We need to know like what day is it, what's the weather, what are the weather patterns of this place. Similarly, you might have multiple knowledge bases. If you're using like one chatbot to ask about HR policy and banking products, you might want to route those to different embedding models, different knowledge bases. You might want to route them to a database query. So that's another place where just you can kind of just optimize this system to make sure that it's pulling the most relevant content because it's not always going to come from the same place. Just to kind of recap, we looking at kind of an end-to-end RAG system, we focused on retrieval errors and kind of like 4 key places you could optimize: how you chunk, how you embed, adding metadata, as well as how you deal with those relevant scores in your retrieval model. And again, the thing I really just want to highlight is that, customization is kind of the key for relevance in your use case. The out-of-the-box models are going to tend to find irrelevant content. They're going to tend to hallucinate. They might be a good starting point. I mean, you might find that you even get 80%. It might even be fine out of the box for your use case, but I think it's good to have awareness of all of the parts of these systems that can be tuned, all the different techniques. Because if you have a very nuanced industry, complex documents, and high requirements for accuracy, you'll probably end up having to tune some of these systems to get the results that you want. So I'm going to throw the QR code up so that you guys can, I think the drill at this point, right? This is how we're collecting feedback. And so we can just have this in the background if there's any questions. Yeah, that's a great question. So the question is, when you're retrieving all of the context, right? So you got, let's just say, 10 pieces that are coming back. Does it matter what order they go into the prompt? I would say, in theory, maybe, but in practice, probably not. Because the idea with systems like this is that you're retrieving very targeted information. So you should have just the chunk or chunks that have your answer. And that shouldn't take up so much of, it shouldn't generate a context that's so large that you start to run into that problem of being lost in the middle. That said, there's really no downside to putting the most relevant parts up front because the model is going to tend to pay more attention to what's up front. But I would say in practice, I've never observed a scenario where performance was degraded based on the ordering of the chunks once you retrieved them. So the question was, if you retrieve context that contradicts, chunk A says the answer is true, chunk 7 says the answer is false. I would say this is where you get into the issue of LLM tuning. From my perspective, I'd say it's probably a roll of the dice if it's going to get it right or not, right? But this is where tuning the LLM to have a preference could come into play, maybe like downstream of the RAG system. And maybe if the LLM's really smart, it would highlight that it's confused. I have seen that before, but I don't think I would, you wouldn't want to necessarily rely on it. All right, cool. Well, if nothing else, thank you so much. Appreciate everybody's time.